Sir, hello.
Yes, yes.
Hey,
So before
Sibsagar.
you start,
Okay.
I want to ask a question.
Yes,
Uh,
yes.
so
Yes.
you have you have talked about the deep learning models and how it requires very large data.
Hmm.
So nowadays one popular deep model framework developed by Facebook is Web2Web. So it is I
Hmm.
think trained approx with 10,000 hours of data. So what
Hmm.
we do is we prepare our small data set and we fine tune it with that data set. That's how we were working with it. So that Web2Web is I think trained with various languages. So one language that is completely not trained with Web2Vec, I mean, that is completely different. So can we use Web2Vec to fine tune it or not? That's my question.
Actually, if there are several language data, that you can definitely suppose in which language you are working.
Currently, I'm working in the African language, Amharic.
Amharic,
Okay.
Amharic,
Suppose
sir. Amharic.
okay. If you are working some African language, then is that language is available on that particular Web2Vec model?
I think yes, sir. I think it is yeah. I think, but the data set is by which it is trained. I think it is small, but we can fine tune it with Web2Vec, I guess.
Hmm. If the data set is available or if the language data is available with that particular case, then definitely you can do it. But whenever we suppose we have a language model, okay, that language model have suppose 100 hours of English data. Now on that case, if you have smaller amount of English data set different from that, you can definitely tune it and you will get good performance, correct?
Yes,
But
sir.
if you are going to tune it with some mixing database, then also you will get some result, but the result will be definitely lesser than the first one. Getting my
But
point? You can
Dipsanga,
do
I
it.
don't, sir, Krishna sir, I don't think in Amharic so much that model support or not, I don't know. Lots of data, I don't think lots of data will be available there in
But we
Amharic
can
because it's
definitely
a low resource language and it is the language of the Ethiopia.
1 or 2 hours of data is available.
then
Yeah.
then I don't think so it will be. But since there will be lots of data, language data will be there, it will definitely improve the performance, but the performance will be not at par with the other resourceful language data. That is the problem with the DNN. That is the problem. Since Web2Vec, I also here because I am not exactly working on the speech recognition domain. That is why I exactly can't comment. But from my understanding point of view, you are definitely working on that. But mm, the performance you have to check. Do you have GMM HMM model with you?
Yes, Kaldi I have, but I have implemented with the Kaldi. But the Kaldi main problem is we need the transcription and the lexicons.
Or you don't have transcription, na?
The transcription I have, but the data set which is very less. I mean, the Kaldi it is
Only
doing
100
very
sentences
bad.
are there. Only we are working on the only 100 sentences and small sentences
Okay.
with recording. So just to test whether it is working or not. One word error
And
rate
it
is
is
so
giving
high.
terrible result.
No, then it will be how it will be working. It will be not possible, na?
Yes.
I will show some result on mini library space database. We are using almost 10 hours of data. Then also it will not giving good result. If you're only taking 100 sentence of data, then it will definitely not give you result.
That we know,
It's
sir.
sure for that. Huh.
Yeah,
In
that
The
we know.
main
in mini
reason,
library space, sir, in mini library space, I think we are using 1500 data for training or 400 data for testing, correct? So it is giving, I
hours,
think, after, huh?
Not
In
our
hours
1500
of
sentences, not
sentence,
ours.
sentence, sentence, sentence.
okay, but that LibreSpeech database sentences are long. I think I am
Mini
using
library
five
space,
or
no, mini library space one, which is on, I think, on 5 hour or 2 hours of data.
that I have using 5 hours of data for training, I think, and testing for 2 hours of data. But my point of view is that because in speech recognition, there are lots of variability. Now you see, suppose in that your Amharic language, how many phonemes will be available?
I don't know.
Oh,
He does not know because we are taking the help of the Amharic students only. Yeah, okay,
We are
then
who
taking.
how
Amharic
you
students
that
are there,
then
they are helping us.
see the basic has to be very clear. whether you are working or not. Suppose you see, if you are going to speech recognition, you have to know about the phoning of that particular language. Then otherwise, how you will able to understand whether the result is coming right or wrong?
No, sir. The three Ethiopian students who knows Amharic, they are
Okay.
our students. They are
Okay.
also with us, and
Okay.
they have prepared the lexicon, transcription, everything.
Okay.
And Sibsagar is only trained that thing. And what the result
Okay.
is also
Okay.
going to verify them only. Okay, because we don't
Okay.
know Amharic. Yeah.
Okay. I
I don't
understand.
know
I
what
understand.
is.
Now see, if there is large amount of variation, and definitely on that case the result will be coming for. There's no doubt on that. You can improve the performance by only increasing the number of data set. If it is not possible, then are you using speaker adaptation on the speech recognition? Hello?
No, sir. No, sir. No, sir.
There is technique. One is called speaker adaptation, means that using that particular information, you are also giving the information about SAT, matlab speaker adaptation technique. Using that, you can improve the performance. What kind of modeling you are using? Monophone, triphone, or what kind of modeling?
Yes, sir. Monophone and triphone. Yes, that is I mean monophone, triphone, and after that LDA and MLTD.
Okay, after that one is SAT. You are using
Yes.
Kaldi script, na?
Yes. Yes.
So on that case,
Note
you
it down.
go,
Okay, note it down. We'll try. So
you go to that SAT, then you will definitely get that particular improved performance. But whatever you are trying, that is okay. But using that less amount of data, it will be very difficult.
sir, we are collecting another 100, and I think we can discuss it later. Okay, and some other time. Okay,
Okay,
Dipshankar,
correct.
let say something. Yeah, because we'll, if we're going to discuss, then this will be late. Yeah.
Okay, sir.
Okay, sir. We'll discuss
Thank
in
you.
detail. I'll contact you, sir. Yeah.
Okay, sure, sir.
Yeah,
I'll be in touch with you, sir.
Okay, definitely. We are asking to collect more
Okay.
data, and then we'll talk. Sure.
ठीक है sir. Okay, I will
Okay, sir.
start.
Yeah. Yes.
So in now I will welcome you all. So I will discuss a case study. Case study means that this particular fusion scheme, whatever we are discussing, now we see the performance of this particular fusion scheme in different speech processing tasks. Now, if you are going in detail in this description, then you have to see, or we are able to understand that what are the minute point we have to think in a particularly when we are extracting the feature. Now I will show many small point where you are able to understand then what kind of analysis can be done in feature level also to improve the performance. Okay, so basically we are discussing 5 different applications of the proposed scheme: speaker identification, speaker verification, limited data speaker verification, replace signal, as well as speech recognition. Okay, in all these applications we are taking 2 sets of data, 2 sets of information, fuse it and apply it, and we are as a comparison we are considering the standard core level fusion scheme as a reference scheme, and try to evaluate the performance of our scheme and see the variation, whatever the variation we are presenting here. Okay, now the first one is speaker identification, speaker verification, limited type speaker verification. So experimental result on speaker recognition task. So here we are, as I already mentioned, we are doing 3 experiments, different: speaker identification, speaker verification, and limited data speaker verification. Now, since we are going to deal with multiple information, so we consider here 2 information. One is MFCC, already you know it is widely used to represent the vocal tag information, and second one is an excitation information. Now, we don't know exactly what kind of excitation information is suitable for our task. Means for a particular speech recognition task, we don't know what kind of feature we are going. We are not blindly using any feature. We are doing some experiment to find out which particular feature is more suitable for our work. MFCC is no doubt the first choice. What will be the second choice? Now, these are the review of the speaker recognition tasks. We have gone through various papers, and we are finding few film, and lots of LP residual features are available in the literature. In case of speaker recognition task, GFD parameter, LP residual signal, LP residual phase, PDSS, MPDSS, RFFTCC. You can find out the abbreviation. It will be long if I'm going to take all this abbreviation name. RMFCC means residual male frequency substantial coefficient, and DCT ILPR. These are the various words where LP residual signals are used. Now, among all this information, we see that these three features are quite used. Just say one is male rep power difference in subband spectrum, MPDSS, residual male frequency substantial coefficient, RMFCC, and discrete cosine transform of integrated LP residual. These three features are widely used. Now, these three features are using in different contexts, different data set, and different environment. Now, for our purpose, for our speaker recognition task, which particular feature vector we are going to use? For that, we are doing two sets of experiment. One is speaker identification, one is speaker verification. Now come to the point. Whatever I am telling that how much we have to check to do a particular set of experiment. In timid database, we are going a GMM-based experiment. Performance of GMM-based speaker identification system with different Gaussian mixers. Now, you know that the performance of the GMM system will be varied with respect to the size. Now, for the timid database, what will be the standard size? And where will be the performance will be more? We are doing an experiment. We're taking MFCC as a single feature. We're taking three mixer size 16, 32, 64, and we are getting the highest identification accuracy 95.39% in 32-bit GMM. Means if we are using 32 mixer size GMM, then only we are giving the highest performance, not less, not more. So we are considering that 32 GMM will be the standard size for speaker identification tasks. And we do the experiment. Now here we are performing the experiment with MPDSS, RMFCC, DCT, LPR, feature, and MFCC. And the combination with MFCC and MPDSS. This combination is done with score level because here we are not using our proposed scheme. Here we are going to find out that what kind of LP residual feature is suitable for us. So you see, MFCC gives individually good performance compared to 3 LP residual feature, and in combination with MFCC, it will also give good performance. Means individually and as a combination with MFCC, RMFCC provide us the best representation. So for speaker identification tasks, RMFCC should be used. In the next experiment, you see in NIST 2003 database, this is a standard database. I think all of you know about it. Here also, the performance will be more on RMFCC individually, and as combination with MFCC also, it will give us the best performance. Means for speaker identification and speaker verification, RMFCC gives us the best performance. So we will consider that RMFCC may be the second feature for our purpose. So first one MFCC, second way we choose the RMFCC feature. Now, since this is an experimental work, we see that we try to do some another level of experiment through which we are trying to find out whether RMFCC will go or not. Now we see a very interesting study. In this particular study, what we do, we check in timid database that what are the files which will be not recognized by any of the feature set. MPDSS, DCT, ILPR, RMFCC, MFCC. What are the speech file which will not recognized by any these 4 features? So 1260 test file, we get in only 15 speaker file which will not identified by any of the feature. Means these are very difficult to identify. There will be something in the test file due to which it will be not able to identify by any features. Now we put the log likelihood, normalized log likelihood curve of actual speaker and identified speaker. Now you see the beauty. Now you see in this graph, we will take some time in this graph. The red line shows us the identified speaker, wrongly identified, because these are the representation of the 15 files. Log likelihood of the 15 files will be not identified by any of the speaker. Now, actual speaker is the given by the black line. Now, if you see the RMFCC feature set, this is the third column, third row. Third row means third feature. If you see that particular diagram, you can see that the difference between the identified speaker log likelihood and actual speaker log likelihood is very narrow. Means RMFCC feature has the highest probability that it will going to recognize the feature, because the difference between the log likelihood of identified speaker and actual speaker is very less in case of RMFCC. Means RMFCC has the highest likelihood to get actual speaker identification in this 15 case. So here also RMFCC doing it very well, and in the other two experiment also RMFCC doing very well. So we conclude, we can firmly conclude that in this particular case RMFCC will be the LP residual based feature we are going to use. Now we came to the next point. Here we find out that we are going to two feature already, MFCC to represent the vocal tag information, and RMFCC is going to the excitation source information, which will be the LP residual base signal. And the LP discussion on the LP residual is already done yesterday, so I am not going to repeat that one. So MFCC dimension of the MFCC will be 39, as well as dimension of the RMFCC will be also 39. Okay. Now we have going various database to deal with this. Now we have three database. One is TIMIT database, IITG MV database, and NIST 2003 SRE database. Why we are using three database? Because these three database give us three different prospect of environment. TIMIT database give us clean condition, IITG MV database give us noisy condition, and last one is give us the NIST 2003 SRE database gives all the possible distorted condition. Means these three database give us three different prospect of our testing environment. That is why we are taking three different data sets. These are the statistics of data sets. Not so many information will be here. This is the IITG MV database. This is the 2003 NIST SRE database. Now we come to the experimental section. Now, as we have already mentioned in the previous experiment, that we have chosen 32 Gaussian size for NIST 2000 for TIMIT database. But for IITG MV database, we have to check what kind of Gaussian mixer size is used here, because here we are using 128, 256, and 512. In 256 data mixer size, we are getting the base performance of 90.11%. Okay, 11%. Now, if you compare this, now this is the final experiment, final experimental result, speaker identification result with TIMIT database and IITG database. Before we comment on our proposed scheme, first we see the performance of the baseline scheme. Now you see in TIMIT database, the performance is 95.39%, and IITG MV database, the performance is 90.11%. Why it is variation? The variation is due to the variation in the testing condition. As I have mentioned earlier, that if the condition is noisy, the performance of the MFCC is degraded. Now you see the RMFCC case. In case of MFCC, the performance is degraded more than 5%, correct? But in RMFCC, the performance is only degraded by 2%. Means in noisy case, RMFCC gives us a robust performance as compared to MFCC. Though the performance is lower than the MFCC, but RMFCC gives us the lower variation in the noisy case. That is why if we combine these two, the beauty of fusion of information comes in this particular point here. If you combine these two, then it will give us a system where the performance is also improving in both the cases. Now you see the result. In score level combination, the performance is improved to 96% in TIMIT database case, and in IITG MV database case, it will be improved to 91.19%. Correct? So fusion of information is improving the baseline performance. Now, if you consider our proposed scheme, so proposed scheme will provide 97.14% as well as 92.23%. Now, in this particular point, you may think that it is only 1% improvement. This is not the case. This is not only 1% improvement. If we have already got, suppose in a particular exam, you are getting 95% by studying 10 hours. Now, if we study 20 hours, how much you will get? Maybe 96, 97, only 2% improvement. But if you are getting 60 by studying 10 hours, if we increase to 15 hours, you will definitely get more than 70. Means if the performance is already at par of 96%, the scope of improvement will be less. So that is why the proposed method provides a 1% improvement as compared to score level. But when the performance is already less, on that case, you will see huge improvement using the proposed fusion scheme. Now we move to the next section. Now we discuss the speaker identification experiment, a speaker verification experiment. In this experiment, we are using 3 databases: TIMIT, IITJMV, and NIST 2003 SRE database. And the performance will be evaluated in terms of EER. We are already knowing all these things. Now, first we came with the TIMIT and IITJMV database. Now here, this table gives us lots of information about the benefit of proposed fusion scheme. Now you see, in the score level fusion scheme on TIMIT database, you can see that the male performance is 2.2 and female performance is 4.27. Means almost double. Female performance is half of the, means here it is less is better. So 2.2 is 2 times better than the female performance. Means in the score level fusion scheme, whatever the standard score level fusion scheme is available, that will give us a huge difference between the male female speakers. Now, if you see the proposed fusion scheme, the male speaker provided 2.02% and female speaker 2.56%. Only 0.56% difference. You can quote 25% changes are there. It means that what it will implicate? Implicate that whether it is male, whether it is female, the performance of the proposed fusion scheme is always consistent. But in case of score level fusion scheme, which is already used by several researchers and lots of people, it will give a huge difference in male and female case. So in gender independent analysis also, our proposed fusion scheme will be performed far better than the score level combination scheme. Now you see the improvement, relative improvement in the proposed fusion scheme. It will provide 45% of improvement. Now it is a very good improvement because the performance is not at par. If you see, if you see this speaker identification experiment, the performance is already 95%. So scope of improvement is very less. But you see here the performance of improvement is large. Where the scope of improvement is large, the proposed fusion scheme provides 95% of relative gain with respect to the score level fusion scheme, where the score level fusion scheme only provides 9.15%. So is it clear that this proposed fusion scheme is far better compared to the score level fusion scheme, where the scope of improvement is present? When it is already par, you have already 95%. How much you will gain from using some additional information? But if you get 60% or 70%, it may go up to 90%, 92% using a smaller variation. So this variation is very huge. You cannot imagine it. In case of speaker variation, this kind of improvement is very large. Now, in case of IIT GMV database, you can show almost similar kind of trend. In score level, it will provide, male case, it will only provide 3.37% improvement. But in the proposed case, it will provide 16%. Similarly, female case 1731, and in overall case 18 and 21. So in all the respect, the proposed fusion scheme provided very good improvement. Now we came to the second point. Now this is the DET plot, not so much to discuss. Now this is the SPC in NIST 2003 SRE database. Now here the performance is 6.91 as compared to 7.32. Here the performance is only 5%. Why it is? This is also because the NIST 2003 SRE database has lots of variation. It will have channel variation, it will have session variation, it will have mood variation, noisy environment, various kind of noise. All the distorted conditions are present in NIST 2003 SRE database. Here the performance will not as per because, as I have already mentioned in the previous lecture, that GMM UBM system is not suitable for adverse condition. For that, we have to go for I vector based system. Now, if we see the I vector based result, we will amazed that I vector based result will be improved so much. Now you see MFCC is 7.54%. Okay. Now you come to the I vector based system, the performance is reduced. The performance is come up to 2.36%, means almost 3 times gain by simply changing the modeling technique. Here you can also find out in score level 8.4% is the score level combination scheme, and proposed fusion scheme is 13.37%. Here also we will have a better performance as compared to the score level combination scheme. Here also the proposed fusion scheme is the winner. Now come to the limited data speaker verification. Here the best part. Here everything is limited. Data is limited. Performance will be also limited because, as we know, that performance of the pattern recognition system definitely based on amount of data. Now, is there any chance that if we have less amount of data and also getting a good performance, how it will be done? So in limited data case, we are testing 5 different conditions: 10 seconds, 8 seconds, 5 seconds, 3 seconds, and 2 seconds. Okay, and we see the result. You will see very good results are coming. Now you see these results. Baseline case, baseline means whatever it is, we are directly using it, no limited data case. MFCC provide 2.36%, RMFCC provide 10.6%, and that result will be already given in this particular table. Okay. Now the overall gain is 4.70%. Now, once that testing data is limited to 10 seconds, performance directly come to 5.23%. Means it will degrade. Come to 8 seconds, it becomes 6.68. And when it becomes 2 seconds of data only, 2 seconds speech data, I am a boy, 2 seconds. This is only amount of speech data through which we are going to identify the speaker. The performance is 20%. Very worst performance, means the performance is decreasing as the number of feature size, number of data size will be decreased. Same case will be happening in case of RMFCC also. Now, if we apply the score level combination scheme, it will improve the performance. The relative improvement is 8.4, 13.76, 16.91. Similarly, the overall performance is 15.57. Now we come to the proposed scheme. You see, In the proposed scheme, in the proposed scheme, the baseline performance is improved by 13% relative improvement. For 10-second case, it is 29. 8-second case, it is 29. 5-second case, it is 27. 3-second case is 31. And 2-second case, it is 28. It means what? Irrespective of the size, the performance is improved by around 29%. Means in the proposed combination scheme or proposed fusion scheme, if we have less amount of data also, it will provide a better performance, you see, as compared to score level. Where the data is less, scope of improvement is more, and on that case, the proposed fusion scheme is provide huge difference, around 15% difference in case of limited data speaker verification. Means if we have limited resource, then you have to use this kind of technique to improve the performance. The conventional technique will not work. Okay, the graphical comparison between score level and proposed scheme with respect to test segment means this will be your 2-second, this will be 3-second, this will be 5-second, this will be 8-second, and this will be 10-second. And you see, irrespective of the size of the test piece signal, it will perform better. The proposed fusion scheme perform better. So up to this point, we can conclude that for speaker recognition tasks, we are discussing 3 different tasks. For speaker recognition tasks, the proposed fusion scheme will provide better and consistent performance with respect to the popular score level fusion scheme. These are the outcome. The most important outcome is the third one. Irrespective of quality, means whether the signal is clean or noisy, does not matter. Whether the quantity of the data is sufficient or limited, does not matter. The proposed scheme always provide better performance than the score level combination scheme. Means there will be no chance that in any case this particular combination scheme will fail. In every aspect, it will outperform the popular score level combination scheme. And second important prospect is the gender independent analysis. The proposed fusion scheme provides stronger consistency. Consistency means in male case, whatever the performance in female case, we will have similar kind of performance. But in score level fusion scheme, the performance will be widely varied. Okay, these are the outcome of the speaker recognition task. So from this particular experimental result, we can conclude, or we can not conclude, conclude is a hard statement. We can say that in speaker recognition prospect, the proposed fusion scheme perform far better than the popular score level combination scheme. Why we are using score level combination is standard? Because score level combination is widely used in many respects, and it is a well-known technique of fusion of information. Now we are coming to the replay detection. As I have already mentioned that Dr. Madhudran Singh already tell lots of things about replay. We are not going to discussing what is replay, how it is done, or etc. etc. We will take a condition. Here we will try to find out that CQCC is the baseline system. It is already given in the PSB spoof challenge. So we are considering CQCC is the baseline. Now we do a literature review and try to find out that what kind of information we are, what kind of LP residual based information is used, because we need to information to fuse the system. So we going in detail in the literature review and try to find out that what kind of excitation source feature used in the review. So these are the features: epoch feature, PRMS, LFRCC, LPRFCC, RMFCC, LFRCC, RPCC. Lots of features are used. But here we are missing some features. First one, what are the features we are missing here? We are missing features like GFT. GFT means glottal flow derivative signal. If you do a literature review, you can easily understand that glottal flow derivative signal is another form of LP residual signal. Okay, and second one is SDC, shifted delta coefficient. This is a very widely used feature in language recognition. But this kind of information, long duration features, higher order temporal features are not used in replay attack, because replay is a very 10 years study. So these kind of features are not used. So we try to evaluate, or we try to see that whether a GFT signal can be used as a feature to replay signal. So in this direction, we are doing it in this way. So this is the database we are going to use, ASB Scoop 2017 version 2.0 database. This is the statistics. Now, since we are discussing the GFD signal can be estimated using 6 different techniques. Okay, so among which technique is suitable for replay attack detection? For that, we are doing a particular study. Now you see, we have GFD signal. We have to derive a feature from GFD signal. Now, what I am telling you from the very beginning, that the quality of the feature and the feature selection is very important for the performance of the system. Now you see, to select a feature, we are not doing the experiment till then, this replay attack. For selecting a feature, how much experiment we have done, you have to check. Okay, because this work I have particularly done in my PhD work, that is why every bit of work I myself I have done. So that is why I am telling you the very particular point where you have to focus when you are designing a feature. Now you see, GFD signal can be estimated by 6 techniques. What kind of technique will be suitable for replay detection? For that, we do a standard spectral distortion technique to find out the suitable combination. Spectral distortion means we take a actual signal and take a replay signal, find out the spectral distortion between these two signals. Using all these 6 methods of GFD estimation. Now, in which method the spectral distortion is more, then the possibility of find out the replay signal is more. So we will find out that IF method will provide the best performance of 0.845 overall spectral distortion. Means among these 6 techniques, the IF method will be useful for estimating the GFD signal. Okay, 1 minute. Estimating the GFD signal. Now, this is not all. First, we are find out the technique through which we can find out the GFD signal. Now, once we get the GFD signal, this is a raw signal. We cannot directly process it, the raw signal, as I have already mentioned you. So we have to do some filtering, or we have to do some processing operation. So what kind of processing we are applying here? What kind of filtering we are applying here? Now you see, in this particular diagram, you can clearly see that the difference between actual and replay signal in the frequency domain will be lies in the lower half of the lower frequency range. And we know that the male substance frequency, male filter bank will have the highest number of filters in the lower half of the frequency band. That is why we are considering the male substance analysis to find out the GFD signal first. 1 minute. Okay, sir, just 1 minute problem. So we are going to use the male filter bank. Now there are many filter bank, male filter bank, triangular filter bank, rectangular filter bank. Now we are using male filter bank. Now to reinforce our use, we are find out the Euclidean distance between all these male filter bank. Now we see the result. Now you see D male means the Euclidean distance using the male filter. D linear give you the Euclidean distance using the linear filter, and D Gaussian using the Gaussian filter. Now you see in the male filter, as we have discussed that using the male filter, we will have the highest discriminating power because the lower frequency band will be changing in the replay section, as we have seen here, that in this part lower half of the plane, lower frequency band plane, the replay changes will be prominently described here. That is why the male filter bank will be properly used. So we are going to use GFD signal and male spectrum analysis. So we will have a feature called GMFCC, and this is the diagram through which you can find out the GFDC feature. This is simple as MFCC. Instead of directly give you the speed signal, we are giving the GFD signal estimated by the IFIF method, and we have already chosen the IFIF method based on the experiment we have done. Now you see, to only find out a LP residual based feature, how many experiments we have to taking place. First, we go to the GFD estimation. There are 6 methods. We are estimating which method is better. We find out IFIF method is better. Then we go for septal analysis. What kind of septal analysis we are doing? We are going these 3 kind of filtering technique, and then we choose that the male filter bank with GFD signal will be the dominant one as a replay signal, as a representation of the LP residual signal in this particular case. So in this particular experiment, we are considering CQCC as the spectral representation and GMFCC as the LP residual based representation. Now we come to the second part of our replay experiment. In this particular experiment, we are considering higher order temporal information. If you have studied a language processing or any language recognition book, you can find out what is SDC coefficient. SDC coefficient, the dimension of the, this is the process. I will show you the dimension first. Okay, it will come later. So in the SDC coefficient, what we are doing it, we are not using the normal delta delta calculation. Instead of normal delta delta calculation, we are using a shifted delta coefficient type of technique through which we are finding out the shifted delta instead of normal delta delta, and we will append to it the original static coefficient and find out the higher order temporal information. In this case, instead of considering 1 or 2 frames from the original frame, we are considering 5 to 7 frames before the original, before the present sample and after the present sample, and getting the shifted delta coefficient. That is why it is called higher order temporal information. This is the structure. Instead of appending, if we find out the append the normal delta delta, you will got CQCC. If you got the shifted delta coefficient, you will got SCQCC. Here, instead of CQCC, we are using SCQCC. Okay. Next, we similar technique, whether the CQCC will be better or SCQCC will be better. We will find out that SCQCC will provide higher Cartesian distance, so we consider SCQCC for this purpose. Similarly, instead of GMFCC, we are using SGMFCC, similar feature, and similar application of Cartesian distance. We are finding out that SGMFCC will be provide higher Cartesian distance, so it is the highest possibility that it will perform as a good feature with respect to the GMFCC. Okay, so now we have 2 features. One is for the excitation source inflow, one is CQCC and GMFCC, and for higher order temporal case, we have SCQCC and SGMFCC. This is similar. We are only changing the next coefficient. Delta delta coefficient is replaced by SDC coefficient. Now, in this case, first we consider that in replay detection, CQCC feature using the C0. Now you see again come the feature selection part, which is very important. In CQCC, we have energy coefficient C naught, we are using C naught. But in RMFCC, we are not using C naught. So whether in GMFCC we have to use C naught or not, for that we do a very small experiment, small experiment to tuning your fisher. Now GMFCC with C naught provide 20%, and GMFCC without C naught provide 16%. So we are going to use GMFCC without C naught. Now there is a small comparison between RMFCC and GMFCC, because RMFCC is the best possible fisher till we have done this work. RMFCC provides 20.88% and GMFCC provides 16.78%. RMFCC plus CQCC provides 9.5 and GMFCC plus CQCC provides 8.82%. Means individually or in combination of CQCC, GMFCC provide better performance. Now we move to the next point. Now we do the final speech detection result with score level and our hybrid fusion scheme. Now in this case, you will provide 28%, 28.4% with score level, and using hybrid fusion scheme, we will provide 31.25%. So we will get a good, we will get a somewhat result which is almost 3% above the score level combination. But the main novelty in this case is that we are proposing GMFCC in this particular case. Okay. Now this is the DET plot, nothing to discuss much. Now we come to the higher order temporal information. Now, as I have already mentioned that higher order temporal information have more number of delta coefficient, shifted delta coefficient as compared to delta coefficient. Now, if we see the SDC configuration, this is the configuration. If we go through the SDC literature, then you will find that NPKF, it will be 21113. So for SCQCC, we will have 126 give us the best result, and SGMFCC similarly 126 size of Fisher vector give us the best result. So we'll select these two Fisher vector and we'll move on. Now this is the final experiment with the higher order temporal information in case of replay detection. So CQCC 12.3%, SCQCC better than CQCC, GMFCC 16%, SGMFCC better than GMFCC, score level 8.6, hybrid fusion 8.10. So we have 33.76%, around 4% gain over the score level combination scheme. So this is the experiment we are doing using proposed fusion scheme in the replay attack detection case. This is the DET plot, nothing to discuss. Outcome of the replay. These are the some outcome. In all the experiment, the proposed fusion scheme outcome from the score level fusion scheme, which just signifies the usefulness of the proposed fusion scheme is replay detection task. Now, till this slide, we are discussing or we are demonstrate the usefulness of the proposed scheme in speaker recognition and replay detection. In the next slide, we are going to discuss the speech recognition prospect, where Deep Shankar and other people are working now. The ASR, we have MFCC. Now, if we find out the literature of the ASR, the fusion of information is very rarely used because it is difficult to fuse the information due to the uniqueness of the testing procedure. In speaker recognition, in replay detection, in everywhere, one speech signal considered to be defining one class, means one speech signal, one speaker. One speech signal, it may be actual or it may be replay. But in speech signal, if one signal is coming, it will have multiple number of phonemes may be there. That is why this kind of fusion is very rarely used in speech recognition. Still, we can get good amount of info, but we are using proposed fusion scheme here, and we are able to find out very good performance. Now you see, outcome of the literature survey is very rarely used. That is why instead of developing another feature like replay detection, we are discussing that we have already two features. RMFCC, which is doing well in speaker recognition, GMFCC, which is doing well in replay detection. So we will save whether RMFCC and GMFCC will be better in speech recognition. Now we do experiment. We do the experiment that RMFCC and GMFCC and monophone and triphone modeling. Now you see in GMFCC case, it will provide far better result than the RMFCC. In triphone modeling, you see it is 57% and in 38% in GMFCC, means around 20% improvement. Only changing the LP residual feature. Now you see, if you are using, suppose I am telling a hypothetical scenario, suppose you are using RMFCC, you are not getting result. You think you will have lots of headache. You are trying many times, but that is not the actual feature you are going to use. You have to change the feature. That is why the importance of features are lying. This is the beauty of feature engineering, that if you choose the feature well, half of the problem is solved. Now you see 78%, almost 21% improvement by simply changing the feature. But this RMFC feature is doing well in speaker recognition. There is no scope of GMFCC. But in speech recognition, you see, GMFCC provides 21% better result. This is the beauty, as I have already mentioned. Now we are doing the Libri speech. Training 5 and development 2 hours. These are the statistics. If you are interested, you may take the screenshot or something like that, or if you can contact me, I will give you later. These are statistics of mini Libri. Now we do the experiment. Okay, we are doing the experiment. I have already mentioned SAD, I have to do na speaker adaptation. So it is monophone modeling, triphone modeling, and triphone with SAD. So monophone 66.31% MFCC, and triphone with SAD it becomes 17.78. You see, from monophone to triphone SAD, how much improvement normal in the MFCC only. And if you clearly observe in proposed fusion scheme, it will provide better than the score level competition scheme. Now here you can see that the performance is not so much well. It is 16.82%, it is 16.11%. Why? Because whenever we are going a speech recognition task, the number of tests will be large, because the WER, whenever we are going to calculate WER, there are a lot of calculations. So in that case, the permutation combination become very huge. So 1% improvement in speech recognition is a huge task. If you suppose the baseline is 15%, if you somehow get 14%, that is a good improvement, no doubt at all. Now this is the outcome of the ASR, as we have already mentioned, that it will perform better than the normal case. So conclusion of this particular presentation, or conclusion of this my work, can be demonstrated in this way, that the fusion of information is very important for getting the optimal result in a pattern recognition case. There are lots of drawbacks in the existing scheme, so we propose a new scheme and demonstrate with 5 different speech processing tasks that our proposed fusion scheme is providing better performance than the existing fusion scheme. Okay, so in the near future, this particular fusion scheme can be applied to fusion of more information. Now in the future direction, the one of the drawback of our scheme is that the feature vector length should be equal to do the padding. So in the near future, dimension mismatch technique can be used like PCA to solve this particular problem. Our proposed scheme is normally used for probabilistic approach. This is cannot be directly used for DNN kind of thing, but nowadays DNN have various generative neural network where probabilistic approach are also incorporated, like GAN or variational autoencoder. I have not done so much work on this particular field, so I exactly don't know how to improve, how to implement it directly, but I think I'm going to work on this particular neural network things using that particular fusion scheme. The hybrid fusion scheme can be used extended to multilingual speaker recognition task, but nowadays one trend is coming out that the speaker may speak many languages. It should not restrict that training is done in English. He will only going to give data in English only. So multilingual means you can train in any language or you can test in any language. So in that case also this hybrid fusion scheme can be increased, and in future hybrid fusion scheme can be applied in any other direction than this particular 5 direction we have done. So this is all about my work or the presentation regarding this. So the forum is open for discussion. If you have any question, I hope you have some question towards me. So please put those questions. I am very happy to answer all these things. Thank you very much. Thank you, sir.
Thank you, sir. Yes, Bala, any questions from your side?
Yes, sir. I have a question.
Yes.
Tell me, sir.
Yeah, sir, can we use information fusion system to handle large scale data efficiently?
Definitely.
Okay, sir.
Okay. I have already mentioned that what are the size of the data, it doesn't matter. If the data is small, this fusion scheme will perform better. Because if already large data is there, then already the existing system will perform better. Only MFCC is perform better if the data is large. If the data is small, then only fusion of information came into place. Okay. Sibsagar, tell me.
Hello, sir.
Yes.
Yes, sir. So you have said about that multilingual, I mean, language diarization. So how can this fusion technique can be useful in language diarization? You can explain.
Yes, everywhere. Language diarization means, suppose you see, if you have a different class in language diarization also, there will be, suppose in a language diarization database, there will be 10 languages. What is diarization? Suppose there is a speech signal, there is a signal, there will be multiple languages. That is called diarization. Now we have to find out from which particular portion to which particular portion this language will be there. Yes? Am I correct?
Yes, sir. Yes, sir.
Yes. So on that case also, you will definitely use it. You are using it speech recognition, you can use it there also. But my point is that if you have sufficient data, then you first try with one feature. Suppose you are getting 80% result. You try to improve it using that feature only. Okay, you go up to 85%. Now you are exhausted that using this feature, it will gone. Now you try to search different feature. When you are searching different feature, you try to search complementary type of feature. Like if you're using MFCC, you don't go for LPCC. LPCC, MFCC almost similar kind of representation because it will both are giving the spectral response. You go for LP residual. Then you find it using any technique, using my technique or using score level technique or any technique, you try to use it. Your system performance will be definitely improved, 100%. Not much, but 100%. That system will be improved if the information is complementary in nature.
Okay,
So
any
you
other
have said
questions?
that, sir, you have said that for ASR technique, this fusion technique is not very popular. I mean, so but you have shown us that by mixing up many features, ASR is also improving. I mean, that GMFCC and the thing is, so in general in ASR, what we do, we use only one feature. We don't use this kind of clustering. I mean,
Correct. The reason is, see.
I mean that's the question. Why we do that? That's the
Why?
question.
Yes. The reason is, see, whenever you are going to deal with any sort of recognition task, first you are finding out the score. Okay, I'm give you one example. in speaker recognition, suppose one test file is coming, compare with one model, it will give one result. It will give one score. That is fine. That is correct. For another model, it will give one score. So suppose 10 models are there. So we will have 10 score. For another feature, we will have another 10 score, and we will do the comparison very easily. But whenever it is come to speech recognition, okay, it will have two kind of matching. One is acoustic matching, one is symbolic matrix, mapping. Now you see, first suppose one speech sample is coming. So first frame coming, do the comparison with the one model. Okay, it will give several score. This is not the final score. With that, again the acoustic part will be coming. I will show you one day. I will give you the here. Oh, it is not here, na. I'll show you the next slide. Okay, 1 minute, huh? I'll share another screen, then it will be very useful. 1 minute. I'll answer it very properly. Don't worry. Cancel. Have you seen my screen?
Yes, sir.
Yes, sir.
Yes. Now you see here. In the testing part, feature extraction is done. First, we do the acoustic matching. Now, if we have two different kind of feature, we have to do the acoustic matching here also. We do the acoustic symbolic matching in the symbolic domain also. So it will become a very tedious work to do the mapping in this particular two domains simultaneously. This is the reason, because it is difficult to do. This is the reason the multiple informations are not used in the ASR normally. But in very rare case, we are using multiple information. That is why you are not finding lots of information or lots of information using multiple information in ASR domain. But it can be doable. In the Kaldi script, there are some files. I exactly don't remember, but there are some file where all the log likelihood probability will be there. Here you have to do this matching technique and can be done. It can be done, no doubt at all. But I have done long time back. It is all around 2 years back, so I exactly don't remember how it will be done. But it can be done. There is a procedure in the Kaldi to find out the log likelihood probability of each feature set, and there only you can do the fusion. But it is difficult. I agree that it is difficult because my work on fusion. That is why using I almost take it is 3 months or 4 months to get that crack that particular point to do it, because I have to do it. That is why I am doing it in speech recognition. Okay, but what people is doing, instead of doing all this difficult work, they are trying to improve the modeling, try to improve the MFCC using new technique. That is the case, because speech recognition, fusion of information in speech recognition is difficult. That is why people are not using it. Okay.
Okay, got it, sir. Got
But
it, sir.
if you have time, yes.
Yes, sir. So the main problem, as I understood that here in that matching part, in normal case, only MFCC is there, so we are only comparing the MFCCs only. But if I take multiple features, then in testing also I have to compute the features and match with that. So it will be, I mean, more compute and more tedious it will be.
More tedious work. You have to do it manually. You have to do some lots of program or lots of Kaldi codes to get these things. And because see, nowadays ASR is doing in Kaldi or some like, but whenever many people think that MATLAB is outdated, something. But if you do a coding like in MATLAB, then you are able to, because MATLAB is licensed version. That is the main drawback. Otherwise, that is the best tool you can do, because here you can find every point very easily. Now, if you go into Kaldi tool, if you're going to find out a particular log likelihood ratio of a particular phoneme, you have to search lot of things, and there will be lot of different format. It's difficult. That is why people are not using. That is why people are going direct standard way, only tweaking in the MFCC, changing the filter structure, number of GMM size, doing it first using some DNN, going to next DNN, RNN, different kind of DNN, transformer structure. They are tweaking on there only. They are not going to the information part. As you have already know that in the DNN, the feature extraction is not also required in some cases. You can directly go in it. That is why they are not doing it. But if we have a low resource language, you cannot go for DNN. If the low resource language is there, the best way is for GMM HMM. But the transcription has to be there for GMM HMM. That is another drawback. So like that only we have to manage. You see, as I've already mentioned, if you have low resource, best way go for feature engineering to improve the performance. There is no other alternative. No modeling technique will perform better without data. Small amount of data. Data has to be more than only modeling technique performs better. Otherwise, you have to go for feature engineering, do the tweaking, and get the result. That's all. Any other questions, sir?
Thank you, sir.
Any other questions?
Yeah, with regard to what is
Yes, Bala, tell me.
hello, sir, can you hear me?
Yes, yes.
Yes, definitely.
Yes, Bala. Sir, here, sir, in our group, most of the students are from the Nigeria. Okay, directly they are
Okay.
joining from the Nigeria and other parts of the world, like Malaysia. Some students are there. So I think, yeah, Bala. Any?
No.
So I think can do something because they are very much interested. Isha is there, Bala is there, who is very active here in this group.
Okay.
Okay, so let us see.
You can do one. You can do one thing. If you have any query regarding this presentation or something, so you just mail me. I'll definitely happy to answer, sir.
Yes, definitely. No, so I will also contact you later with the students only. Whatever students will be wants to do or they want to do some.
And
project,
I'm very much comfortable with speaker recognition, replay detection.
Okay, sir.
You can ask me anything regarding this. In speech recognition, I have some knowledge, but it's very difficult to do in Kaldi, and I forgot all these things.
Yes,
but regarding the speaker recognition and replay, you can contact me anything. I'll definitely help. And
we'll try to start that work also. Sir, that
yes,
bird sound, okay? That also we'll try to discuss in detail.
Definitely. And I'm also visiting Orissa when Jagbandhu will come, then definitely we will meet, sir.
Yes, definitely. We just come. I am in Bhubaneswar only. From the childhood only, I am in Bhubaneswar. Born and brought up here only. So anytime you can come, I am here. Okay, and you are also invited to see Jagannath temple. All the things you can visit.
Yes, sir. You know Poti, sir, na?
Poti.
Devadatta Poti?
Yes. He is now in Ramadevi University. Yes, I know him.
No. No, Devadatta Poti, Prasanna sir student in NIT Nagaland.
No.
Oh, you don't know, na?
He is from Odisha. Poti title is from Odisha.
Yes. He is from Cuttack.
Yes. I am planning to go to Kamakhya in between this 22 to 26th in between. Let us see whether holiday I will get holiday or not from the leave or not from the university.
Okay.
Okay then, sir.
So, sir, thank you very much.
Thank you very much, sir.
Touch, sir.
Definitely, we'll be in touch.
Thank you,
okay,
sir.
we'll do some work. That's the main objective. Okay, sir. Thank you very much.
Okay. Bye bye, sir. Bye.
Bye bye.
Thank you, sir.